Hello, ladies and gentlemen. You have stumbled upon the first lesson of the first chapter of Math 1. It's all about the number line, and we're going to be trying to figure out where fractions, mixed numbers, square roots, in some cases decimals, where they belong on a number line in which the only things that are marked are, it seems like every other tick mark is a half, and then you got whole numbers after that. So, as we investigate this, the first thing I want to point out is that this is exactly halfway in between 0 and 1/2. And it's important to understand that a half is exactly 0.50 as a decimal. I'm kind of counting on everybody to come in with that basic knowledge. So halfway between a half and 0 is the same as halfway between 0 and 50. It's 0.25. So what's the fraction that corresponds with 0.25? Well, it's exactly 1/2 divided by 2, which if I cut a half in half, it becomes 1/4 or a quarter. So now, once we establish that this notch right here is a fourth, we can say with pretty good certainty that each little jump of a tick mark on this number line represents a quarter more, or 0.25 more. So you have a fourth, then a half, then it would be 1/4 more. So 1/4, 2/4, 3/4. And you just keep adding 25 to this one here. So that's 0.75. So that's basic stuff I wanted to get out of the way before we really dig into the examples we've got here. So I've got 1, 2, 3, 4, 5, 6 examples that I want to plot in this first number line. The first one is the fraction 10 over 19. Now there's two different ways that you can think about this number in particular. First of all, you can just straight up turn it into a decimal. The process for turning 10/19 into a decimal with long division is you always put the numerator, the top number of the fraction, inside the box. The denominator always goes on the outside. And then what we do is we basically just add a place value. We're just saying, okay, 10 is the same as 10.0. And then you just start asking yourself, all right, how many times does 19 go into 100? I actually have a shortcut, though. It's like, here's a thought bubble over here. 10 over 19 looks really close to a familiar type of a fraction. I don't know if this jumps out at you, but 10 over 20 is exactly 1/2. Okay? Stay with me. So if 10 over 20 is exactly a half, 10 over 19 is really, really close to a half. It's either a little bit less than a half or a little bit more than a half. So the question becomes, is there a way to just straight up see it right off the bat and tell ourselves, oh yeah, that's bigger than or less than a half? Well, think about it like this. What is exactly half of 19? Like, we figured out what exactly half of 20 was. It was 10. All right? But 19, exactly half of that would be 9.5 or 9.5. So this value is equal to 1/2. 9.5 over 19 is exactly a half value. So when you compare that to 10 over 19, let's think about that. 9.5 over 19 is equal to a half. Therefore, 10 is 0.5 on the top exactly more. So that's bigger than a half, but just by a little bit. So because we can maybe use this logic, we can just say, I don't have to do any of that division inside the box. I can just say it is a little bit more than a half. And I can find my half on the number line. It's right here. And I'm going to put a point, a dot just to the right of it. And then I'm going to point to it and say it's the letter A. It's just to keep things organized and neat on this number line. Things will get things might get complicated if we just start throwing numbers right there. So that's letter A. Check that one off the list. Now, if you're curious about how this division is going to actually go down, 19 goes into 100. 20 goes into 100 5 times. 20, 40, 60, 80, 100. And 19's just under 20, so 5's a good guess. Then you take 5 times 19, so it's kind of like 5 times 9 first, which is 45. Then you would carry the 4 here. 5 times 1 is 5, plus 4 is 9. Okay, so that was a great guess. 95 is just under 100. Then you subtract. And this is the point where in division you drop another 0. It's sort of like, all right, 10.0, that's the same thing as 10.00. Yeah? So then it's 50. This is the point actually where you can start to just form your conclusion right away. Because it's like, it's 0.5 with something else beyond that. So 19 goes into 50 twice. That's all we need. We know it's 0.52. We know it's just a little bit more than 0.50, which was a half. So take a look at this and ask yourself, do I like just going and doing the division? Or do I like to think about it outside the box and say, hey, I know this is true, so maybe I can make a connection over here so I don't have to do all this extra legwork over here. All right, let's check out some others. Letter B. You got negative 47 over 11. So right away we've got two things going on. We've got a negative number, which means we're going left from 0 on the number line. And we've got a number that's much bigger than the denominator. So we can do a couple things. We can convert it into a mixed number. I would advise you to do that if you're like really good with quick calculations, like 11, 22, 33, 44. Okay, there's 4 of them. With 44 and 47, there's 3 left over. Okay, if you're not so great with it, you might have to be just stuck with doing the division manually from the get-go. So you might be thinking, I don't know, that's probably going to take me longer. I may as well just do 47 divided by 11. So you got 2 different options. You can explore over here, or you can just get right to it. So here, 11 goes into 47 4 times. We already knew that. 4 times 11 is 44. You subtract 3 difference, 30. 11 goes into 30 almost 3 times, but not quite. So there's a 2 there. 2 times 11 is 22. Subtract again, and there's an 8. So again, you're going to drop a 0 from that phantom hundredths place of a 0 there. And there's an extra one. So 80. 11 goes into 80 7 times, right? 7 times 11 is 77. And you kind of got your answer right here. What's a really close number that compares to 4.27? 4.25, right? So then I'm going to go all the way to negative 4 on this number line over here. Because remember, it was negative to begin with. And now I have to ask myself, does 0.27 in the left direction, is that... So right here is negative 4 1/4. This is negative 4 1/4 plus a little bit more. All right, so that means I'm going left, all right, left of negative 4 1/4, all right, on the number line, and I'm labeling that my second one. All right, now I want to show you guys something interesting with this particular fraction. Notice if I kept going with these calculations. All right, so we're coming back to the calculation here. You would drop another 0, and you're right back to where you started again. It's 30. Okay? So 11 goes into 30 2 times. And then so 22. When you subtract, it's, again, 80. We're just repeating this pattern over and over again. It's a repeating decimal. And I guess what I'm trying to point out here is that the 11ths always have a repeating decimal And it's actually very interesting. See that 2, 7, 2, 7, 2, 7? Two 11ths is 1, 8, 1, 8, 1, 8. 4 11ths is 3, 6, 3, 6, 3, 6. Do you guys see any patterns here? What would 9 11ths be? It's 0.818181. It's basically that number times 9 gives you the repeating decimal. 2 times 9 is 18, 3 times 9 is 27, 4 times 9 is 36, 9 times 9 is 81. Interesting stuff here. All right. Just wanted to point that out for you guys so that if you ever see an 11ths and you have this committed to memory, you don't have to do the division. And I'm all for shortcuts. But the good ones, where you came up with it in your brain. All right, so part C, 1 7/9. So right now, 7 over 9 is 7 over 10 is 0.7. So we know it's ranging past 1.5. The question is it bigger than 1.75 or not? So this is one where you'd want to get the decimal for 7/9. You don't even have to mess with the 1 out front. So 7 divided by 9 would be, let's see here. 9 goes into 77 times? Yeah, 9 times 7 is 63. And then we've got, oh boy, we got another pattern here. So 70, okay, 7 and 63, and 7, 63, so, okay, got another pattern for you guys. The 9ths are always that decimal repeating. So 7/9 equals 0.7 repeating, 8/9 equals 0.8 repeating, 1/9 is 0.1 repeating. So I guess with this particular example, 0.7 repeating would be a little bit more than 1.75. So you're going to the right of 1.75. Interestingly enough, based on the pattern, what would 9/9 be? Interesting. I thought 9 over 9 was 1. Oh boy. It's rocking our world. All right, got that. And then again, part D is just another example of a mixed number where we need to figure out what the fraction looks like. So 5 over 7. You put the 5 in the box, the 7 on the outside. This really doesn't require us to do a whole lot of extra work here. It's kind of like boring, same kind of 7 goes into 50 how many times? Make sure your decimals lined up. 7, 49. 7 goes into 10. Once, bingo, it tells us exactly how to compare it to 0.75, the closest tick mark on there. So it's -1, 0.71, so this is approximately -1.71, right? So I'm going to go all the way to -1.75, which is like -1 3/4, and say it's not quite there. It's -1.71, not -1.75. So it's going to go to the right of that tick mark. And we'll put a little d here to designate that. All right, lastly with this example, the root 10s, the square root 10s, what I'm getting at there is for you guys to remember the list of perfect squares that are around root 10. So root 9 is 3 times 3. Root 16 is 4 times 4. Root 10's got to be between 3 and 4. And it looks like it's significantly closer to 3 than it would be to 4. So with this lesson, I just want you to know that, hey, it's 3 point something that's much closer to 3.